All right, looks like it's 10:45, so I'm going to go ahead and get started. Welcome everybody to the second day of Ignite. Hope your time here has been well spent thus far. Looking forward to speaking to you today about software-defined networking in the Windows Server 2016 server platform. How many of you guys were at the software-defined data center breakout just before this? Okay, so Ravi Rao talked about software-defined networking, and I'm going to be a little bit more hands-on, more practical in the application of that today. My name is Jason Messer. I'm a program manager on the Windows Server networking team. I've been with the product about 2 years, and before that I worked for the Defense Department doing a lot of network security analysis and protocol work. It's kind of a bait and switch. We were going to have Greg Costanza here. He backed out. Then I was going to have Christian Sabatia here, and then he backed out. So I hope they don't know something I don't know or something like that. All right, so Windows Server 2016 is really built around the three pillars you see here. It's all about security, it's all about software-defined data center, it's all about a cloud-ready application platform. We've done a lot of work in Server 2016 to build in layers of security through things like shielded VM, the host guardian service, guarded fabrics. We've also done a ton of work, which we'll talk to you today, about software-defined networking for the software-defined data center and how that ties into other software-defined technologies such as Storage Spaces Direct. And then, of course, Server 2016 also brings support for containers, which is very exciting as well. So why are you here, though? I know why I'm here. Why are you here? Chances are that you have some sort of interest in data center networking. You have created an infrastructure, your network administrator has created an infrastructure on which you want to layer certain network services for your tenants, for your departments, for your business units, so on and so forth. But the challenge becomes then how do you manage all of these services in the common data center, in your data center? We have things, gateways, virtual networks, access control lists, load balancers, all sorts of different networking appliances, policies, services that we have to manage and manage well. I am just now seeing that these slides are not the slides that I had planned, so I'm going to quickly do a switch and go to my laptop. So just play some elevator music for you. How many of you are familiar with software-defined networking? Okay. I love it when things just go so smoothly and as planned, and I spent late hours last night making sure this was all ready. Okay. All right, so back to where we were. All right, so we've been talking with customers for the past 2 years as well about some of the challenges they face. A lot of challenges really can be boiled down into these three sets that Ravi talked about in the previous session, around agility, around security, and around flexibility. We simply do not have time to wait for new networking policies to be applied at physical layer switches anymore or in firewalls. We need to have these workloads up and running in a matter of minutes or hours, and not days to weeks. And obviously the question we get asked a lot is, Azure can do this, why can't I in my own data center? The other challenge we face a lot is security. There are so many new zero-day attacks coming out literally every day, so many new vulnerabilities. And we need a way to instantaneously react to those vulnerabilities and to be able to lock down the network so that those attacks can't either get in the front door, or if they have gotten in the front door, to propagate out further. So we need to apply policies quickly and have a strong security stance. We also want flexibility. We don't want to just be limited to this application has to run on this rack or the world will end, or it won't work anymore. We need the flexibility to be able to process different system downtime. If we want to scale up a workload for whatever reason, we need the flexibility to do that as well. Or perhaps we even want to take advantage of some of the Azure cloud services and have a hybrid cloud deployment. We need all of this flexibility to be able to do that. And that's what a lot of you guys have been telling us, that this is what we need. So we've listened to this, and we've seen these network services that have come on as a plane on top of the physical infrastructure. And so how do we manage this? Well, in Azure, we have multiple services running, obviously, like Bing, Office 365, and various tenant workloads. And so what we've done, basically, is to bring that technology to you in Windows Server 2016, so that an admin, through a network portal, can actually, I'm realizing now that I'm going to have to switch to my laptop when I'm doing these slides. I apologize. A network admin is actually going to have to, or an IT admin is going to manage these services through their portal itself. All right. I really apologize, guys. I'm not sure why this is not keeping up with my presentation. Let me try one other thing real quick. I'll go back to the Surface and put my USB stick in there. And now, let's see if we can present from here. All right, this looks better now. Okay, so I don't have much time. So what really the practicality of this talk is going to be is actually defining or deploying this software-defined networking fabric, which I've alluded to, in under 60 minutes. So how many people think I can do it? Under 60 minutes, bring up all of the SDN fabric. How many people think I'm going to fail and have an epic fail up here on stage in front of you all? Okay. Well, I'm going to still wrestle because this monitor isn't working on my laptop now. This is ridiculous. Let me switch over to my demo machine. Yeah, just reboot. Go to the home screen so you don't have to see all the ugliness that I'm doing behind the scenes. All right. Okay, so this is a real lab deployment that's actually in our lab back at Microsoft itself. I'm going to go ahead and use System Center Virtual Machine Manager to deploy this SDN fabric. And then at each step along the way, I'll show you what sort of tenant operations you can do with the fabric components we've just installed. So I'm logging in right now. All right, System Center is now up. What we have basically is I'm going to start off with the network controller service template and deploy that network controller. And before I do that, I'm actually going to start a timer just to show you that this is under 60 minutes. And we'll check in with that every once in a while. Okay, so I'm going to give this a name. This is going to be my production network controller that I'm configuring. Then I'm going to enter specific credential and other resources that I want to configure on this itself. I have a security group, which I've previously defined in my Active Directory. I also have a place for diagnostics and traces if anything were to go wrong that I can save off. Go ahead and give it an account with the right credentials to be able to write to that directory. And then I'm going to actually tell it what accounts to use for running the network controller application and the network controller node VMs, which are running behind the scenes, as well as what network I want to connect this to. And again, I'm flying through this now just because my timer is running, but we're going to go back and explain this in more detail. Again, the management account that I'm using, password. And I don't want you to get bogged down on all the steps today. The main goal is for you to understand the process and the workflow, and then you can go back to the video, see me stumble through the first 10 minutes, fast forward through that, and then we'll go ahead with the deployment itself, which you can reference back. And lastly is certificates, because we do want to have security on not only, we want to have security in the control path as well. Now what I'm going to do is go ahead and refresh this preview. If any of you have used System Center before, you're probably familiar with the service templates that are supplied. Have you guys used service templates in the past? Few people. Okay. So now it's going to go ahead and look at my infrastructure that I have and make sure I have the resources I need to actually deploy this. I have 3 network controller node VMs, which is for resiliency and redundancy. I'm going to go ahead and give these some static IP addresses. I'll zoom off while I'm doing that. Each node is connected to the management network. And finally, I'm going to give these VMs a name that fits what my actual data center is. The naming conventions that my IT guy has given me. I'll refresh this one more time just to make everything in place. And then we'll go ahead and deploy this service and go back to the presentation. This process takes about 25 minutes. This is really the longest piece in the SDN Fabric deployment itself. Okay, back to the presentation. All right, so there's still a lot of hype around software-defined networking. So what is it? Any answers you can shout out? One word.
Logical networking on top of physical networking.
Logical networking on top of physical networking.
You actually have control management data plane.
Control management data plane, yeah. There's, it's hard to nail down a real definition to this, but when we have identified what that value proposition is about the challenges that it can solve, we still have a lot of concern, I would say, from IT admins and especially network admins as well. Saying things like, it's too time consuming, it's just too complex, this technology is brand new, I really don't understand how to use it. A lot of other pejoratives, I would say, that just too whatever. And so the real value proposition, though, is what if you could do these things? What if you could solve your challenges to deploy new tenant workloads quickly, bring up IIS web servers, scale them out through a load balancer, apply network security policy quickly? And easily. What if you can move those workloads very, very simply from one server to another or even across different sites? Those are the value propositions and what I want to focus on. And so we have these hero scenarios where if you're a large enterprise or if you're a private cloud hoster or even a service provider, you have the ability really to bring up this fabric quickly and then start deploying new tenant workloads very, very quickly, and to be able to apply new security policy in a data center or to attach an on-prem installation to an Azure to take advantage of some of the hybrid cloud services. Very, very quickly, all these things can be done. So let's back up a minute and talk about some of the core SDN terms and concepts and how Microsoft sees the world. So this is somewhat of an eye chart, but I want you to give the idea about the different layers, the different abstractions that we use to talk about these things. At the top, you basically have a management portal, a management plane, which is your interaction with the system itself. This could be through PowerShell scripts. This could be through a System Center Virtual Machine Manager, or the center picture represents Azure Stack, which will sit on top of this platform that we're building. And so all the different resource providers and Azure portal that you get with Azure Stack will nicely just fit on top of this. That allows you to define the policy that you need. That policy is then sent down to a highly available network controller application, which is actually running on the Azure or on Service Fabric in Windows itself, to maintain quorum, to maintain resiliency, maintain state. That computes the policies that you've defined in the management layer, and then that control plane layer pushes those down to where they're actually enforced in the data plane itself. This is what gives us massive scale, because instead of having to look for policies each time new packet flows come up, we already have the policies applied down at the physical host itself, in the Hyper-V host, through a switch extension, which is from Azure, Azure Virtual Filtering Platform extension, which is essentially our flow engine and policy engine to allow us to define different overlay virtual networks using VXLAN encapsulation, to define access control list rules, to define quality of service queues, so on and so forth. Now that's all great for east-west traffic or traffic within your data center to be able to have different tenant workload VMs communicate with each other. But what if you need external access? Or what if you need to have more scale by load balancing these services across multiple sets of the same instance? Well, to do that, we have gateways and we have a software load balancer. The software load balancer, not only can it act as a load balancer to do a round robin and distribute connections across the back-end sets of services that you want to access, but it can also provide outbound NAT connectivity, and it can provide inbound NAT rules to access certain resources for that north-south traffic coming in. Not only that, it can also load balance east-west traffic. So if you have multiple tier application, you can actually go ahead and set up a web tier and maybe a database tier or application logic in the middle and have those connections be load balanced across as well. On the left-hand side of the picture, you'll see the SDN gateways. We have various types of these gateways that are all multi-tenant aware, so that you can have a forwarding gateway to go between your virtual and physical networks. Or you can have a site-to-site gateway using an IPsec tunnel or a GRE tunnel to provide multi-data center connectivity or external access. And really the goal, again, is to scale this out to the Hyper-V host, to the data plane layer itself, so there's no bottleneck. Again, another challenge, I think, when we're talking about software-defined networking is to come up with a standard set of terminology. And so just like some of the other competitors in the industry, we have a manager through System Center Virtual Machine Manager. We have our controller, which is a homegrown Azure-inspired network controller for that control plane. We have a vSwitch. The key difference, I would say, or the key terminology discrepancy that we often run into is the difference between virtual network and logical network. In System Center and in Microsoft parlance, we just call the virtual networks the one that's the VXLAN overlay encapsulated network, basically. The logical networks are more on the physical networking plane with the different VLANs assigned to them, IP prefixes, and so on and so forth. And we'll get into more details on that in just a minute here. Okay, so perhaps you're convinced, you understand the value proposition, you want to be able to deploy service quickly, get new security policy to block attacks, be able to have the flexibility to move workloads around, but you still need to convince your network admin. And so I think the way to do this is really to set kind of some common concerns, some common areas on which you can collaborate on. Because at the end of the day, both the IT shop and the network admins are concerned with security. They want to make sure those workloads are locked down, that no vulnerabilities are exposed. They also can't afford system downtime. They have to make sure that service is reliable and resilient against failures or changes. And they have to deploy services quickly. It's not enough to say, I submit this change request or this ticket and I'll get to it in a few days. No, the customer in your department needs this service now, like as in yesterday. And so these are things that resonate with both IT shops and the network administrators themselves. And so you're bringing them into this conversation. You're not saying that we don't need networking anymore. We'll all do it in software, because that's not true. But we are beginning to have this conversation about, well, where can those security policies be best applied? What does it look like to be able to scale out through a software load balancer? I would say the important step then is around discussing the requirements that you still need the networking people to do. There's still cabling that has to be done to connect the Hyper-V host, the physical servers, to the TORs, the top-of-rack switches. They still need to have the right VLANs trunked from the switch ports to the physical servers themselves. They're still concerned with different routing, either static routes or dynamic routes with BGP peering or OSPF or whatever the dynamic routing policy is. They're concerned with latency and the tolerance for loss and different firewall policies. So all of these are conversations that we can actually have with the network admin as we're deploying the software-defined networking infrastructure, the fabric. And so the biggest takeaway, or one of the biggest takeaways from today, is really to start with a plan. We've done lots of these deployments before, and the biggest challenge is just making sure we have the network admin and the IT admin in the same room discussing the same exact thing and making sure they know simple things like what IP addresses are these going to be assigned to? What's the route and reachability I need to this network? So we have a few different types of logical networks, those physical networks that we define for management traffic, for tenant traffic, and of course if you're having storage traffic. So really briefly, we've created a planning topic on TechNet to help lead you through this conversation with the goal of filling out a table like this. So you can say my management network is on this IP subnet. It's on this VLAN, and I can assign these IP addresses from that subnet to my management infrastructure. Or I have an HNV provider, which is actually used as the transport to carry my encapsulated traffic for tenants. I have a transit network, which is that north-south network to provide external connectivity with the outside world, and also to exchange BGP peering information, which we'll discuss when we talk about the software load balancer. And then finally, the public and private VIP pools. We need to be able to give external clients or external customers a way to actually access these virtual network resources. And so we do that through public VIPs. Or if it's only internal data center access, then we can do that through a set of private VIPs. Of course, the IT shop also has to do some planning, and so we've provided this information as well, because not only are you hosting your tenant workload VMs, but there are also some SDN fabric infrastructure VMs that have to be brought up, which we're in the process of doing right now with the network controller. And so here's the workflow. Again, please don't get bogged down with the individual steps, but the high-level workflow is this. We're going to deploy fabric infrastructure. This is step 0. This is already done for me today in my lab at Microsoft. This includes things like setting up the Hyper-V host, giving them physical network connectivity. Next, we're going to deploy that network controller, which we kicked off just a few minutes ago, through System Center Virtual Machine Manager. After that network controller is onboarded, after that first fabric component is there, we can actually start bringing on tenant workloads. We can start attaching tenant VMs to these virtual networks that we've created. We can assign access control list policy to them and quality of service queues to them. Next fabric component we want to deploy for our SDN fabric is the software load balancer. Again, this is for external access through either outbound NAT or some inbound NAT connections coming in, and also just for distributing the load as it's a layer 4 load balancer. Tenant side, after we've deployed the SLB, the software load balancer, now we can start creating some tenant VIPs and saying, tenant X, please give this address out, this IP address out to one of your customers who can now access your resources through our software load balancer. Or if the tenant needs to have outbound NAT for internet connectivity or external network connectivity, they're able to do that now as well. Configuring inbound, outbound NATs, the tenant operation. Finally, there's the last fabric component, which is the gateways themselves, either site-to-site gateway or forwarding gateways. And then finally, if we have time, we'll see about creating a site-to-site VPN tunnel to actually connect the networks together. So that's the high-level workflow, which we'll keep coming back to. So fabric infrastructure, step 0. Again, review the plan. What's the plan? What's the IP space that I have available? What's the IP pools that I can assign to this class of systems? And so for the first part of the fabric, I'm going to have basically 4 IP addresses that I can assign. I have 4 Hyper-V hosts, physical servers in my lab. That's the pool from which I can assign the IP addresses for those, either statically or through DHCP. Teaming becomes an issue as well and something that network admins are concerned about. We have a great new technology, which Don will talk about on Friday, called switch embedded teaming, which actually brings that team directly into the Hyper-V virtual switch itself. We've optimized our stack to work with 2 NIC team members. And so in my deployment, again, as you'll see, I have 2 NICs that are attached to 2 redundant layer 3 TORs. And so I'm assigning IP addresses and VLANs to those. So this is what it looks like pictorially. Usually you start off with a compute cluster and then a fabric management cluster. In my case, I've kind of combined those 2. And so the system center, SQL, SCOM is all running on the 4th host. The other 3 are going to hold my SDN fabric infrastructure VMs and tenant VM workloads. So I've created a management logical network. I didn't do this in my lab because I'm not using storage, but you would create a storage logical network as 2 for the RDMA type traffic if you're using converged networking. And then what I've done is I've created a logical switch in System Center Virtual Machine Manager, and I've deployed that switch out to all the hosts and given them network connectivity to the management network through these VNICs. So now this is what our logical network diagram looks like. We have a set of 4 hosts, and they're connected to one network. This is all we're starting with. Let's go ahead and review that. Check on my time as well. "17 minutes, okay. All right, so I'll zoom in here, and we can see the different fabric cluster that we have. Again, System Center is only managing these 3 hosts right now. And I've defined that management logical network and given it the IP pool that I showed you previously. Now, I've attached all the Hyper-V hosts to that management logical network through a logical switch, the SDN switch, and given it some port profiles to actually be able to have that connectivity to the management network. And so that's all you're seeing here. We have 3 Hyper-V hosts that are onboarded through VMM. They have a management logical network, and that management logical network is attached through the VMM logical switches. So that's pretty much ground zero and what we have with our fabric installation so far. All right, so after the fabric's brought up, after you have the IP addresses assigned for management traffic and the right VLANs trunked on the right switch ports, excuse me. We're going to go ahead and deploy the network controller. So again, looking back at our plan, we know when we're deploying a highly available network controller application that we have 3 network controller node VMs. Each of those network controller node VMs need an IP address from the management network. And so that's why I've assigned 3 there. Optionally, if you have multiple fault domains and you want to be able to transfer that reachability to the network controller across one IP address, you can actually dedicate a separate IP address for the network controller's RESTful API so that it's always available and transitioned across. Okay, so what does our deployment look like now? We're going to start by downloading that service template, the network controller template from GitHub, from a repo that you see there on the bottom of the screen. We'll go ahead and import that template into VMM. And then we're going to deploy, or actually we're going to customize the actual service template that I showed you very quickly previously when we first launched the demo. And again, going through that, if you've seen a service template before, this will look somewhat familiar, but it's basically just a set of parameters and options for specifying the different credentials, the resources that I need, what networks to connect to, and how I'm going to secure that network connection between VMM and the network controller using a specific security, or a X509 certificate rather. I can then do some further customization by actually specifying what the name of that VM is going to be and what its management IP address is. So that's all that we did at the very beginning of this when we launched the demo. All right. So best practice, each network controller node should run on its own Hyper-V host, just for fault tolerance reasons. Those network controller nodes are attached to the management logical network, as I described before. And so now we have a few things that happen. We have a network controller host agent that's running on these Hyper-V hosts to provide that control path, southbound we call it, between network controller and the devices themselves, which is a secured control path, and it allows us to propagate the policy that we've defined down to the individual hosts themselves. Now that network controller host agent is actually going to program our flow engine, the Azure Virtual Filtering Platform switch extension in the vSwitch, which enforces all of that policy that we've defined. We'll onboard that service into VMM so that we can take advantage of it through PowerShell automation or through some of the GUI. And so now what we have is this picture. We have our Hyper-V hosts that are connected to that management logical network, and we have a set of infrastructure VMs that we're now attaching to the management logical network as well. Who's still with me? I know this is a lot. Okay. Great. So the question was, why 3 network controller nodes? You don't need 1 per host. No, it's just that I have 3 hosts, and I'm providing a highly available service. The way I do that is by having that network controller application running on a service fabric ring, as we call it, if you're familiar with the technology. So that provides resiliency against any of those nodes going down, provides some quorum management. It also separates out some of the individual services that are running and spreads that load out across the different network controller nodes themselves. Okay, let's go back and we'll check on our installation. And failed. This is where I go to my video. Okay, so let's continue on where we would have left off. Let me go back just a little bit here. Okay, after that controller was deployed, I'm going to add it to VMM through a network service. To do this, I got to specify what that service name is going to be for my infrastructure. And then I'm going to tell it how to actually connect to that service and what admin account to use to run it. This connection string allows me to do that. Says this is the the REST endpoint, a domain name through which I can communicate with that network controller piece. And then it references the actual service that we imported and configured and deployed, which happened to be network controller production. At this point now, we're going to go ahead and check some of the certificates that we have, because again, we want a secure control path, so we verify that this is indeed the X509 cert. I'm using self-signed certs in this environment, but you can use CA-signed certs just as easily. Then I'm going to go ahead and scan this provider. Network controller is a provider, and so I want to make sure it's accessible now through VMM. And indeed, it says it's up and running. It's good. Then I'm going to tell it what host group to import, or to deploy, actually. So it's going to add that network device into VMM. At that point then, we can run some diagnostics, some basic checks just to make sure the system is healthy. And so I wrote a PowerShell script, which is available on GitHub, basically, to check and make sure that that the network controller service is deployed correctly, that the different services are up and running. And I do that through a set of PowerShell modules, specifically the network controller PowerShell module. And I have to give it a credential by which I'm going to access the network controller, because it's going to check its state. We have some diagnostic commandlets built into the server platform itself that allows me to actually check on the configuration state of each of these resources. So there's server resources, there are virtual network resources, load balancer resources, all of these fabric and tenant resources. We want to make sure they're healthy and consistent with the state that's in the network controller itself. Just by virtue of the fact that there's no errors reported, this is saying, yes, everything looks healthy so far. I'm going to go ahead now and look at some of my servers themselves. Each server that I onboarded through VMM has a corresponding server resource on the network controller itself. And so I can look at one of these resources by the resource ID string and actually see what its connection properties are. I picked the third server, for instance. Go ahead and give it what the ID is of that. And it's JSON is the output, actually. It's the data modeling language we're using to represent these resources. And so you can see the certificate, base64 representation of the certificate that's being used to communicate with this server, the management name, management IP address of that server itself. So at this point, the SDN fabric looks healthy. The network controller is up and running, it's responsive, and the server resources are correctly onboarded. They know where those are at. The next part then is to deploy some, actually I'm going to stop there and go back to my presentation, just a minute. So after that service is onboarded, we can continue moving on. Since we have a highly available network controller service, one of those nodes is actually acting as the primary, which is represented in green here. And so an admin through VMM now can access the network controller resources to deploy and create all these different logical networks and tenant policy. All right, so now we have an SDN controller up and running, a network controller up and running. We can start doing stuff with it. We can actually start onboarding some tenant VM workloads. And so to do that, the first thing we have to do is create another logical network as a transport for that encapsulated traffic itself. We call that logical network the HNV provider network. And so I'm going to go ahead and create this logical network and give it a name, HNV provider. And I'm going to specify this is what the purpose of that network is. It's basically to act as the encapsulated packet header for the tenant traffic itself. I'm going to assign two PA IP addresses, two HNV provider IP addresses to each host. For the specific purposes, I want to take advantage of the switch embedded teaming that I alluded to earlier. And so we've optimized for a 2NIC team member solution, so I'm giving it two PA IP addresses. I'm also going to have to work with my network admin based on that table that I filled out to specify what the VLAN ID of this network is, what's the subnet prefix that I can use for it. After I create this network, the next step is to actually create an IP pool from which I can pull addresses from. So I'm going to go ahead and add the IP pool. And again, we have two HNV provider addresses per Hyper-V host, which is needed to know for planning purposes, obviously. So I'll give it that static IP pool. And I'll reference the logical network site that I just previously created. Now I'm going to specify what that pool is. Again, working with my network administrator, I have .64 through .78 to give these Hyper-V hosts. Tell it what the default gateway is to get out. And then we'll move on. Now at this point, I have that transport, that HNV provider logical network. And so I can start building tenant virtual networks on top of it. So let's go ahead and do that now. So I'm going to create 2 tenant networks. Oh, before I do that though, I do have to add the HMV provider to my logical switch, because that logical switch now is connected to both the management network and the and the HMV provider network. Now at this point, I can start adding some VM networks for tenants. And so I'll create 2 tenant virtual networks, a red tenant and a green tenant. I'm going to speed this up just a little bit due to the sake of time. So I've created a web subnet and a database subnet for each of these tenants. Created the red tenant app. I'm going to do this. Green tenant is now created. Its IP pools for web are instantiated. And now I have some VMs that I can actually attach to these as well. I can check to make sure everything looks good. Again, going back to some of my diagnostics and checking on the virtual networks. I'm going to go ahead and see what the address space is for these, 192.168.1/24 and .2. And you notice maybe that they are using overlapping IP addresses because that address space maintains its isolation using VXLAN encapsulation. So even though I'm using the same private IP space for both the red tenant and the green tenant, it's okay because they're not going to conflict with each other due to the VXLAN encapsulation. So now I have a pre-created VM template for running Windows Server 2016 IIS, basically. I'm going to go ahead and deploy that. And I'm going to deploy an instance for the red tenant and then 2 instances for the green tenant. Can go ahead and select what its IP address is, what network to connect it to using the VMM console. And I can give it a static IP address if I so choose, or just leave it to be dynamically assigned. Repeat that step for the other VMs. And choose which hosts I want these VMs to deploy onto. At this point, I can start logging into those VMs and actually checking out the resources that I created. So for this one, I've logged into the red web VM. And I can check and make sure that its web page is going to be accessible through that east-west traffic path that we've created. Shows me that I'm connected to these 2 networks. They have connectivity to each other. And I can actually access now their web pages using that .1.4 address. But since I want to guarantee that isolation between the red tenant and the green tenant, I want to make sure they're not stealing each other's secret recipes. Also can show you now from the green tenant's perspective that yes, indeed, if I go to the same IP address, it's actually going to hit a different web server, which I've created previously. Okay, going back. All right, while that demo was running, we talked about the HMV provider address space, the IP addresses for that. We also talked about how those networks were created and onboarded. Created the HMV provider logical network. And so now we have management logical network and HMV logical network, which are trunked to the Hyper-V hosts themselves. We then created the virtual networks, the green and the red tenants virtual networks. We created these things called PA host VNICs, which again are just for managing the encapsulated packets. And then from a tenant's point of view, this is what it looks like. We've actually deployed those VMs on these particular servers. So now our logical network diagram has grown up, and it looks like this. We have some virtual subnets defined, which are actually encapsulated inside of that HMV provider logical network itself. We already showed this in the video, deploying the virtual networks in VMs. And so here's where we're at. Deployed the fabric, deployed the SDN network controller, and deployed some tenant VMs. Go ahead and do a time check even though I'm on video now. But that process usually does take actually around 35 minutes when I've timed it previously. All right, software load balancer. This is the next Fabric component we want to bring in. The software load balancer needs a new logical network defined for north-south traffic and for having the BGP peering information route advertisements propagated from the software load balancer muxes to the top of rack switches. And I'll discuss more about that in a minute. So now these SLB MUX VMs, which we're going to configure and deploy, have connectivity to the management network, the HMV provider network, and also the transit network for north-south traffic. So go ahead and switch over to that video. All right, so I'm creating this transit logical network again through VMM. You should be somewhat familiar with this process now. Again, this is for north-south traffic. After we set up the logical network definition and that site, we're going to go ahead and tell it what VLAN to use and what connectivity this network should have with the rest of the infrastructure itself. And it's going to be managed through the network controller. Add the site to all these host groups, or to all the hosts in this host group. It's going to be on VLAN 11 with a specific IP address space shown up here. At that point then, again, just like we did for the other logical networks, we're going to create an IP pool. This will be the IP address pool or range from which the SLB MUX will pull from. And so the network controller, when it's actually deploying this load balancer, will know these are the IP addresses I need to assign from that transit network to the software load balancer MUX. Go ahead and give it a range. You can tell it what its gateway is. And at this point, I'm going to now add that transit logical network to the logical switch so it has connectivity across all of the hosts. And just as I did for the network controller, I'm going to configure and deploy this software load balancer template. Again, this template is available on GitHub. And has a few options or a few parameters that I need to specify. Again, just like the network controller, I have to say what the local admin account is I want it to run as, what the management network is it needs to be attached to, and what the certificate information is, and what the transit network is. So I go ahead and fill in these parameters, and then I'm going to go to this service template designer and customize either the names or IP addresses of the individual MUX VMs themselves. Just validating that this is indeed the certificate I want to use. It's based on the same network controller certificate to protect that northbound traffic between the VMM console and the network controller, using that same certificate, this time just with the public key for authentication purposes. This is just showing me importing it to the right location for VMM to be able to pick it up. Copy it into the right folder that needs to be, and then continue on with my configuration. Specifying the names of these MUX VMs, and then go ahead and starting to deploy this service. The SLB usually takes about 10 minutes to deploy. We'll go ahead and go back to the slides while it's running through the video to show what we've done. All right, so we created this transit logical network through VMM. Now we're going to go ahead and download those service templates from GitHub again from the location there. We're going to import them into VMM. And we're going to configure that service template to match our infrastructure with the correct credentials and logical network references. Again, this is a production template, and so it's going to be highly available, which means it's going to have 3 node VMs deployed across the host. This is the screen we saw previously in the video. We're going to continue on, and now those software load balancer MUX VMs are going to be on the system itself, on the Hyper-V hosts. We've also connected them to these 3 different logical networks: the management, the HMV provider for encapsulated traffic, that's the back-end traffic, and then also the transit network for the front-end traffic for external connectivity. So now our logical network diagrams come somewhat more complex. We've added a new logical network, the green transit network at the bottom with that IP prefix and VLAN. And we've connected the MUX VMs and trunked the right that VLAN to, from the switch port to the Hyper-V hosts themselves. All right. So it's not enough that we have the software load balancer connected. We also want to provide access to it, either externally from outside the data center or internally from within the data center, using these public and private VIPs. One of the private VIPs will be reserved just for planning purposes, so you know. One of them will be reserved for the software load balancer manager. That'll be for it to communicate and make sure the service is up and running. Go ahead and go back to the video, show you how we create those. At this point, it's rinse and repeat. Go ahead and create that service instance. Show you that it's running on these 3 VMs. And now we're going to create the public and private VIPs for external access. We'll tell it what subnet we've given it. Again, working with our network administrator who has to give out these IP prefixes since they are routable. Did that for the private VIP and create an IP pool for it. We used all the addresses in that range, .34 through .38, for the private VIPs themselves and marked them as being reserved for load balancer VIPs. Do a similar operation with the gateway, and then we're going to go ahead and create public VIP. Again, this will be the external one that we hand out to external clients and customers. Tell it that it's going to be managed by a network controller and it's going to be a publicly available address space, which means it's going to be routable externally. So at this point now we have the public and private VIPs and their IP pools. I'm going to stop there and explain a little bit more about VIPs and BGP. All right, so we created the public and private VIPs. We went ahead and added another host agent, the software load balancer host agent, to make sure that whatever tenant workloads are running on that Hyper-V host, we want to make sure that they're healthy and stable. And so we have a host agent that not only applies the load balancing policy, but also makes sure that the Hyper-V hosts are healthy. All right. BGP peering often scares people. It often scares the network administrator, saying, why do you need BGP? We use BGP for route advertisement for the next hop of either a load balancer or a site-to-site tunnel endpoint. The way to think of BGP is through the concept of these autonomous system numbers, or ASNs. These are essentially administrative groups which host a set of routing prefixes that you or I would own. And then also they can peer then with a different set of IP addresses from a different management zone, or ASN, which they're going to share that information with. So in our case, we have the software load balance MUX, which have an ASN of something in the private ASN range, 64628 in my case. And it's going to be peering using the BGP protocol with the top of rack switch on a different ASN, 64623. Now this allows us to actually advertise routes, not only for that special software load balancer manager on the private VIP space, but also a tenant VIP. And so a tenant VIP is going to be coming from the public VIP pool, and it's going to be advertised out through the router using BGP to say the next hop to get into this network is actually one of the software load balancer MUXs. So .160, .161, .162 are assigned to those load balancer MUX VMs. So that's all we're using it for. It doesn't have to be propagated out any further than that. We can actually use just that private range. All right, going back to our logical network diagram, now we've added that private and public VIP, and we have it routable with the transit network so that we can provide north-south or external connectivity. All right, so let's go ahead and do this in VMM now. So we're going to configure, oh, that went way too fast. We're going to configure this load balancer rule and say what the service is that it's going to attach to, what VIP pools should be associated with it. Go ahead and choose the SLB production service instance, again referencing the same connection string we used for the network controller. And then we're going to program in this ASN information for all three muxes and give it peering information so that it knows how to peer with those layer 3 TORs up above. At this point, we can actually look at our switch configuration or ask our network admin to look and say, hey, is this route advertisements being sent up correctly? And so I do a show IP BGP command on my top of rack switch. And indeed, I see that this software load balancer manager IP address is peered. The routes to that are peering successfully, and it's accessible through those 3 SLB MUX VMs. All right, so going back to slides. Next step is, now that we have this fabric component, we can actually start using it for tenant operations like load balancing and for inbound and outbound NAT. So we'll go ahead and do that. So this is what the diagram looks like. We have our network controller VMs or MUX VMs, and we're adding these new elements, BGP peering, to exchange that routing information between the MUXes and the top of rack switches. All right. To enable a tenant to actually use this, we create something called a VIP template. This specifies what the front end port is and what the IP address is through which I want to access my back end resources. We create a VIP template through VMM and then actually advertise that tenant and create the tenant VIP through a PowerShell, System Center PowerShell. What that does then is it basically deploys these load balancers. Again, we can have different load balancers for different logical load balancers for the different tenants with different spreading involved. And it's peering that information out, those routing advertisements out through BGP, so that an external client through the public VIP can actually access those green tenants virtual network resources. Similarly, if it's an internal client, then we can have an internal client maybe wants to do an inbound NAT, an RDP to one of these tenant VMs. And so it can do the same thing inbound just from the private address space. All right, so let's go ahead and see what that looks like. More VMM. What I'm doing now is, again, creating that VIP template, which specifies what the front end port and what the back end port are that I want to load balance. And so the virtual IP port is that front end port, and I'm going to just say that it's going to be 8080. Could be any number of things. And then the back end port is going to be port 80 for my web server instances. I'm going to go ahead and tell it what the template type is. It's a network controller template. I'm going to tell it what the protocol is to use. In this case, it's TCP. And I'm using round robin load balancing just because that's what our software load balancer, that's the algorithm it supports today. All right, so after this point, now that I have that tenant VIP, I can actually start using it. So I want to see what VMs do I want to load balance across. So I have a PowerShell script, again, posted on GitHub that enables you to specify what the VIP template name is, what the VIP IP address is, and what the VMs are that it should load balance across. And so I'm going to go ahead and run that script. And that's going to complete the process of onboarding the tenant VIP and start advertising routes through that VIP for the back-end resources. All right, so now when I hit the 10.127.132.34 page, which is one of my public VIPs, I can see that it's going to red web VM1 running on 1.4. If I open up another tab, I can see it's going to 1.5. So it's successfully load balancing across those two. Okay, so that's great. We have tenant VIPs. Next step, what about inbound and outbound NAT? It's not enough for external access to these virtual network resources, a lot of workloads that are on board and need to have internet connectivity. So we need to create outbound NAT rules for those. Similarly, we might want to provide RDP access to one of these VMs, and we only want to provide that in the internal data center network itself. So we can go ahead and create this outbound NAT rule for the green tenant, and we can provide an inbound NAT rule for RDP, for instance, for the red tenant. All right, here's where we're at, coming back. Deploy the fabric, network controller, tenant VMs and virtual networks, load balancers deployed, tenant load balancer VIP is deployed. Now we're configuring the inbound and outbound NAT rules. And at this point, we can just do massive policy deployment. And so I've written some scripts, which unfortunately I won't be able to show live, but basically shows you what the type of policy that you can define through PowerShell is. So I can create tenant networks, specifying what the IP address ranges are. I can run my diagnostics to check and make sure those are up and running. I can also create tenant VIPs using PowerShell automation. I can run some diagnostics. And I can deploy the world. I can create multiple VNets. I can create multiple ACLs, all just at running this simple PowerShell automation script with examples that are actually posted on GitHub for you guys to look at. So again, we started off with a very, very simple deployment, 2 tenants, but now we can automate this to create multiple tenants, multiple access control lists, multiple load balancer rules, and multiple VMs attached to those networks, all just by running these PowerShell scripts. Very, very quick and easy to do. All right, time check. See where we're at. It looks like we're at 51 minutes now. And yes, indeed, if I did do the live demo, it would still be about this fast. So rest assured, I'm not trying to fool you. Okay, last thing. We want to deploy some gateways. Check back with your network admin. We need those public VIPs through which we can access site-to-site tunnel endpoints. And we're also going to add one more new logical network, the GRE network, so that if we have a GRE tunnel, we can actually use GRE. All right, so what does this look like? We've downloaded the gateway service template from GitHub. Again, rinse and repeat type operations. Imported it into VMM, went ahead and configured the gateway template itself, created the GRE VIP logical networks, deployed those gateway VMs to my Hyper-V host as well. And while I was doing that, just like I did for software load balancing, I also configured the autonomous system numbers, the ASNs, so that I can access my virtual gateway or my virtual network through a virtual gateway front end. I can also exchange routing information. I can either program this statically on each end of the tunnel, or I can use BGP and dynamically have it peer and advertise those routes for my tenant networks. All right, so last thing we're adding, the muxes, the gateway VMs. Okay, so the gateway infrastructure is in place, SDN fabric. We're going to go ahead and create a site-to-site VPN tunnel now. So we can envision we have a remote site, or maybe we even have Azure cloud that we want to access. We want to provide our virtual networks access to through a public network like the internet. So again, we're going to put up this load balancer as a front-end endpoint so that remote clients can connect to the virtual gateway on the cloud side. That's going to be advertised through the public VIP and accessible through the public VIP. And then I'm going to have another virtual gateway or site-to-site tunnel endpoint on my remote site or in Azure. And finally, I can just create the site-to-site tunnel by doing that. I am almost out of time. Again, just as easily we can create a red tenant site-to-site tunnel network as well. All right, so what just happened? So we deployed the SDN fabric components, deployed network controller, deployed software load balancer, and I would have shown you we started the deployment for SDN gateway. That piece extended out just a little bit past 60 minutes. We also created the tenant virtual networks with different access control lists, load balancers, NAT rules, site-to-site VPN tunnels, all in under 60 minutes, hopefully. Can be done. So lastly, the message I want to leave you with is just the cloud-inspired network for your data center itself. We can deploy this faster. I hope I showed you through VMM GUI how you can deploy these things and configure these things, and then also through the power of PowerShell automation can rapidly deploy massive amounts of these different resources. All using VXLAN encapsulation for our tenant overlay networks, using SDN gateways for multi-site and connections into Azure, and also external access through software load balancers. We've enhanced the network security posture. Greg Costanza is going to have a talk about this on Thursday, talking about microsegmentation network security groups and getting into the details of our distributed firewall to know how you lock it down. And lastly, we have a talk on Friday about how we reduce costs and increase performance. Don Stanwyck will be talking about converged NICs with RDMA for storage traffic, quality of service, and I'll also be doing a brief section on monitoring and diagnostics for the SDN fabric and tenant infrastructure itself. Quickly going back, these are the new capabilities we've brought in to the SDN infrastructure. Very powerful stuff. And the key thing to remember is that all of this is included in Windows Server 2016. It's not an additional package you have to buy outside of that. This is all included. All the gateway functionality, all the software load balancing functionality, and with the right NICs and drivers, a lot of the performance capabilities as well. We have some documentation, some resources. We're starting to blog more on TechNet. We're also using GitHub as a repository, not only for example scripts that we put up and diagnostic type troubleshooting steps, but also we want to engender a community whereby you guys can contribute as well. So we have had several people already contribute, and we've merged some pull requests from the external community to actually make our diagnostics better, our scripting solutions better. So I'd really encourage you guys to do that. Finally, please do evaluate this session. And with that, these are the upcoming sessions. Ravi, Matthew John, Siddhartha Roy talked already about the software-defined data center earlier this morning. Greg's talk is Thursday at 2:15, and Don's talk is on Friday at 12:30. I'd really encourage you, we have a hands-on lab that I'd love for you guys to try out as well. And with that, is there any questions? I'll be around afterwards, but thank you for your time.